This is a picture of penguin leaf waste in our school, which is SMAN 3 DENPASAR in Bali. Because there's a lot of that leaf waste, we are curious, like what compounds do the leaf contain? And we found out that the leaf contains benzene, which is an ingredient for making an after. That's why we are coming with a title, Exploration of Bioafter Potential of Frangipani or Plumeria acuminata leaf extract through distillation process. With me, Risa Paramitha, and
my name is Kadek Dwi Cahyarani.
We are from SMAN 3 DENPASAR. Now we are going to starting our project. Okay, in Indonesia, we heavily rely on imported aviation fuel with unusual usage of 5 million kiloliter per year. And this high demand and dependence on imports drive up airplane ticket prices, partly due to the high cost of after. Also, fuel's consumption gives a big impact on the environment. After fuels also contains complex chemicals such as short and medium chain hydrocarbons. Besides that, frangipani leaf waste extract also contains acid that is also found in hydrocarbon chains. On frangipani leaf waste also found that there is a benzoic acid, benzofuran, xylene, heptadecane, hexadecane, and octadecane. They are dominant in aviation fuel and play a significant role in increasing the octane number. The process of converting leaf waste into bioafter involves distillation or separation of product fraction to obtain the desired bioafter components. This can maybe a solution for many other countries because apart from Indonesia, frangipani flowers grow a lot in Mexico, Central America, and Caribbean islands. So, our purposes of our research is the first one to determine the quality of bioafter from frangipani leaf waste through distillation process. The second one to determine the fulfillment of frangipani leaf waste as bioafter through distillation process against Standard National Indonesia of after. There is also the method of our research. The research method used is the experimental method. This type of research is quantitative research with a descriptive approach. The data obtained in the form of pictures and statistics will be presented using a descriptive approach, and the research object used is frangipani leaf extract or Plumeria acuminata. The research stages of making our bioafter. The first one is we are cutting the leaf into small pieces, and then we do the maceration using N-hexane, and then we let it sit for like 24 hours, and then after that we drain the extract, and then we collect the extract to do the distillation process, and after that we do the testing using 6 indicators, namely flash point, freezing point, total acid number, sulfur content, density, and viscosity.
And this is the result and discussion that we have. Based on the table, there are 4 indicators that are close to the Indonesian national standard for aviation fuel, namely sulfur content, viscosity, density, and freezing point. For the freezing point test, 5% of the extraction was mixed with jet fuel. Then the freezing point value was obtained at the temperature of min 56 Celsius. The lower the freezing point temperature, the better the quality of the air fuel. Bioafter from frangipani leaf waste extract test for sulfur content obtain a figure of 0.0064%, and this is due to the purification process and the low sulfur content of frangipani leaf waste extract. The low sulfur content in bioafter can help maintain vehicle engine to last longer. In the density test, the results obtained are close to the Standard National Indonesia on after, which is 686.3 kg per meter cubic, and the size of the specific gravity of bioafter is caused by the chemical composition and the chemical properties contained therein. In testing the viscosity of the liquid, the results were obtained at 6.257 mm² per second, and if liquid is easy to flow, then the viscosity is low, whereas if a liquid is difficult to flow, then the viscosity is high. And why the flash point and acid number not close to Standard National Indonesian after is because the flash point test, the results obtained are not all close to the Standard National Indonesian on after. Because in the table list, Standard National Indonesia flash point of after is 38 Celsius, while for BIOAVTUR in flash point testing is 25 Celsius, which means the sample is flammable at room temperature when it contact with fire or heat. For acid number testing, the results obtained are far from the Standard National Indonesia of after. In the table list, Standard National Indonesia acid number on after is 0 until 0.015 mg KOH per gram, while the sample test result obtained 0.0528 mg KOH per gram. Samples that have a high acid number content are likely to be in contact with oxygen for longer. And the conclusion of this research is frangipani leaf waste has the potential to be used as an ingredient in bioafter production through distillation process. And the second is for the of 6 bioafter research indicator from frangipani leaf waste through distillation process, namely freezing point, sulfur point, density, and viscosity, are close to the Standard National Indonesia for conventional efficient flow. And further research is very needed to improve the quality of frangipani plant leaf waste as an alternative source of bioafter, so that is meets Standard National Indonesian after. So from this research, we know that the frangipani leaf waste has the potential to be used as an ingredient in bioafter production through distillation process, and 4 of 6 research indicators are close to the Standard National Indonesia conventional efficient flow. So that's it. Thank you for our